Hello students, welcome back to another session of science class. In our last class, we have discussed some concepts about sound. In this class, we will discuss some more concepts about sound. Okay? Students, let us now discuss about sonic boom. When the speed of any object exceeds the speed of sound, it is said to be travelling at supersonic speed. Bullets, jet aircrafts, etc. often travel at supersonic speeds. When a sound producing source moves with a speed higher than that of sound, it produces shock waves in air. These shock waves carry a large amount of energy. The air pressure variation associated with this type of shock waves produces a very sharp and loud sound called the sonic boom. The shock waves produced by a supersonic aircraft have enough energy to shatter glass and even damage buildings. Okay? So students, let us now discuss about reflection of sound. Sound bounces off a solid or a liquid like a rubber ball bounces off a wall. Like light, sound gets reflected at the surface of a solid or liquid and follows the same laws of reflection as you have studied in earlier classes. The directions in which the sound is incident and is reflected make equal angles with the normal to the reflecting surface, and the three are in the same plane. An obstacle of large size which may be polished or rough is needed for the reflection of sound waves. So students, let me draw a diagram for you so that you can better understand about the reflection of sound. Okay? Students, as we have discussed, this is the direction of sound. Sound travels in this direction and this is the surface which is being polished, or it is a rough surface, suppose. So, this is the point at which this sound gets in contact with the surface, and this is the point from which the sound is reflected in another direction, because it cannot penetrate through the surface. So, it falls on this point and reflects in another direction. So, at this point, if we draw a perpendicular line, that is called the normal, and the two sounds, the sound that is incident at this point and the reflected sound, they make same angle with the normal, and the sound that is incident and the reflected sound and the normal, they are on a single plane. So, this is a plane and they lie on the same plane. In this case, both the angles have the equal value. Suppose this is x degree, this is also x degree. They are exactly equal to each other. Okay? Students, let us now discuss activity 12.5. It says, take two identical pipes as shown in figure 12.11. You can make the pipes using chart paper, or else you can bring pipe if you have in your home. Okay? The length of the pipes should not be sufficiently long. Arrange them on a table near a wall. Keep a clock near the open end of one of the pipes and try to hear the sound of the clock through the other pipe. Adjust the position of the pipes so that you can best hear the sound of the clock. Now measure the angles of incidence and reflection and see the relationship between the angles. Lift the pipe on the right vertically to a small height and observe what happens. Let us now think what is going to happen. Okay? Students, you can clearly observe after measurement that the angle of incidence is equal to angle of reflection of the sound. Now, if the pipe on right is lifted for a smaller height, what will happen? The sound cannot go through the pipe. Why? Because it is maintaining a particular direction with a certain angle of reflection. So it will move in that particular direction only. If we lift the pipe up, then sound cannot go through that pipe. It will go below the pipe. Okay. So it will not be audible because we are placing our ear against the pipe on the right, which is now lifted up. So this is to be kept in mind that these two pipes have to be in the same plane. When we lift the pipe on right above, then it is on another plane. Now the pipe on left and the normal, they are on a single plane, but the pipe on right is now on another plane above the plane where the pipe on left is lying. That's why it is said that the sound or the incident sound and the reflected sound and the normal, they have to be on the same plane to observe or to verify the reflection. Okay? Hope you understand this. Students, let us now discuss about echo. If we shout or clap near a suitable reflecting object such as a tall building or a mountain, we will hear the same sound again a little later. This sound which we hear is called an echo. The sensation of sound persists in our brain for about 0.1 second. To hear a distinct echo, the time interval between the original sound and the reflected one must be at least 0.1 second. What does it mean? It means to distinguish between two sounds, okay, the differentiation between the original sound and the reflected sound should be at least 0.1 second. Otherwise, we cannot distinguish between the sound, and if we cannot distinguish between the sound, we cannot say that we are hearing echo, because both the sound will be similar to our ear and we cannot differentiate. When we differentiate, then we can say that okay, we are hearing an echo of the original sound. If we take the speed of sound to be 344 meter per second at a given temperature, say at 22 degrees Celsius in air, the sound must go to the obstacle and reach back the ear of the listener on reflection after 0.1 second. If it reaches within 0.1 second, then the listener cannot distinguish between the two sounds. Hence, the total distance covered by the sound from the point of generation to the reflecting surface and back should be at least 344 meter per second into 0.1 second. Okay, 344 meter per second. This is the speed, okay, and we need the sound to come after 0.1 second. So 1 second, it gives us 34.4 meter. Fine. So the total distance travelled by the sound, okay, the total distance travelled by the sound should be 34.4 meter. What does it mean? That means the sound should travel, it contacts the surface of reflection and comes back to the listener. This total travelling distance should be 34.4 meter. Thus, for hearing distinct echoes, the minimum distance of the obstacle from the source of sound must be half of this distance. Okay. To listen the echo, what we found that the sound must travel 34.4 meter. That means total distance covered. So it goes like this and reflects back. So this is if the total distance from point A, this is O, this is B. So, OA plus OB should be 34.4 meter. So, what should be the distance of the listener from the obstacle? It should be 34.4 by 2, or it is up to 7.2 meter. That means to hear an echo, the listener must stay 17.2 meter away from the point of impact, or we can say the obstacle from which the sound is being reflected back. Okay? And this distance will change with the temperature of air, because we have already discussed that temperature is a factor which affects the traveling of sound. Okay? Echoes may be heard more than once due to successive or multiple reflections. The rolling of thunder is due to the successive reflections of the sound from a number of reflecting surfaces, such as the clouds and the land. Hope you have understood this concept. Students, let us now discuss about reverberation. Okay? A sound created in a big hall will persist by repeated reflection from the walls until it is reduced to a value where it is no longer audible. The repeated reflection that results in this persistence of sound is called reverberation. In an auditorium or big hall, excessive reverberation is highly undesirable. To reduce reverberation, the roof and walls of the auditorium are generally covered with sound absorbent materials like compressed fiberboard, rough plaster or draperies. The seat materials are also selected on the basis of their sound absorbing properties. So, students, this is the difference between echo and reverberation. Okay, reverberation happens in a hall or in a big room. Why does it happen? It happens because of continuous reflection of sound. And why continuous reflection happens? Because there are multiple reflecting surfaces. After generation of sound, sound faces multiple reflection of surfaces. So, this continuous reflection, okay, is called reverberation. But while traveling, the intensity of sound decreases. That is why the reverberation does not go long. It stops after some time when the intensity of sound decreases. Okay? Students, let us now discuss example 12.2. It says a person clapped his hands near a cliff and heard the echo after 5 seconds. What is the distance of the cliff from the person if the speed of the sound is taken as 346 meter per second? So, let us discuss the solution. What is given? It is given speed of sound, that is 346 meter per second. Fine. What else? Time taken for hearing the echo. So, T is equal to 5 seconds. Distance travelled by the sound, by the sound is equal to Vt, or it is 346 into 5. meter. So, sound should travel 1730 meter. Okay. So, in 5 seconds, sound has to travel twice the distance between the cliff and the person. Hence, the distance between the cliff and the person should be, can you find it? Yes, it is half of the distance, that is 1730 divided by 2. 865 meter. That is why the distance between the cliff and the person should be 865 meter. Then only he hears the echo after 5 seconds. Okay? Hope you understand this. Students, let us now discuss uses of multiple reflection of sound. Megaphones or loud hailers, horns, musical instruments such as trumpets and shehnais are all designed to send sound in a particular direction without spreading it in all directions, as shown in figure 12.12. Just go through the book and you can find the figures. In these instruments, a tube followed by a conical opening reflects sound successively to guide most of the sound waves from the source in the forward direction towards the audience. Stethoscope is a medical instrument used for listening to sounds produced within the body, chiefly in the heart or lungs. In stethoscopes, the sound of the patient's heartbeat reaches the doctor's ears by multiple reflection of sound as shown in figure 12.13. Generally, the ceilings of concert halls, conference halls and cinema halls are curved so that sound after reflection reaches all corners of the hall as shown in figure 12.14. Sometimes a curved soundboard may be placed behind the stage so that the sound after reflecting from the soundboard spreads evenly across the width of the hall. Just go through the figure 12.15. Students, let us now discuss a question given in your book. It says, why are the ceilings of concert halls curved? Let us now discuss the solution for it. Okay? Students, the ceilings of concert halls are curved so that after reflections from the surface, sound can reach each and every part of the hall. So, hope you have understood the answer of the question. Let us now discuss range of hearing. The audible range of sound for human beings extends from about 20 Hz to 20,000 Hz. Okay. What is Hz? Hz is 1 cycle per second. Children under the age of 5 and some animals such as dogs can hear up to 25 kHz. 1 kHz is equal to 1000 Hz. As people grow older, their ears become less sensitive to higher frequencies. Sounds of frequencies below 20 Hz are called infrasonic sound or infrasound. If we could hear infrasound, we would hear the vibrations of a pendulum just as we hear the vibrations of the wings of a bee. Rhinoceros communicate using infrasound of frequency as low as 5 Hz. See, students, we cannot hear this sound because the range is 20 Hz to 20,000 Hz for human ear. So, though there is sound around, it is not necessary that we can hear all the sounds. We can hear the sounds those are created within the range or within our hearing range, that is 20 Hz to 20,000 Hz. Whales and elephants produce sound in the infrasound range. It is observed that some animals get disturbed before earthquakes. Earthquakes produce low frequency infrasound before the main shock waves begin, which possibly alert the animals. Frequencies higher than 20 kHz are called ultrasonic sounds or ultrasound. Ultrasound is produced by dolphins, bats and porpoises. Moths of certain families have very sensitive hearing equipment. These moths can hear the high frequency squeaks of the bat and know when a bat is flying nearby and are able to escape capture. Rats also play games by producing ultrasound. Students, let us now discuss about hearing aid. People with hearing loss may need a hearing aid. A hearing aid is an electronic battery operated device. The hearing aid receives sound through a microphone. The microphone converts the sound waves to electrical signals. These electrical signals are amplified by an amplifier. The amplified electrical signals are given to a speaker of the hearing aid. The speaker converts the amplified electrical signals to sound and sends to the ear for clear hearing. Okay? Students, let us now discuss some of the questions given in your book. The first question says that what is the audible range of the average human ear? I hope you understand this question and I know you know the answer. So what should be the answer? The audible range of the average human ear is from 20 Hz to 20,000 Hz. Okay? Then the next question is, what is the range of frequencies associated with infrasound and ultrasound? Let us discuss the solution for this question. Okay? Students, for infrasound, the range is less than 20 Hz and for ultrasound, it is greater than 20,000 Hz. Hope you understand the solution for the questions. Students, let us now discuss the applications of ultrasound. Ultrasounds are high frequency waves. Ultrasounds are able to travel along well-defined paths even in the presence of obstacles. Ultrasounds are used extensively in industries and for medical purposes. Ultrasound is generally used to clean parts located in hard to reach places. For example, spiral tube, odd shaped parts, electronic components, etc. Objects to be cleaned are placed in a cleaning solution and ultrasonic waves are sent into the solution. Due to the high frequency, the particles of dust, grease and dirt get detached and drop out. The objects thus get thoroughly cleaned. Ultrasounds can be used to detect cracks and flaws in metal blocks. Metallic components are generally used in construction of big structures like buildings, bridges, machines and also scientific equipment. The cracks or holes inside the metal blocks, which are invisible from outside, reduces the strength of the structure. Ultrasonic waves are allowed to pass through the metal block and detectors are used to detect the transmitted waves. If there is even a small defect, the ultrasound gets reflected back, indicating the presence of the flaw or defect. You can see figure 12.16 and know how it is being done. Okay? Ordinary sound of longer wavelengths cannot be used for such purpose, as it will bend around the corners of the defective location and enter the detector. Ultrasonic waves are made to reflect from various parts of the heart and from the image of the heart. This technique is called echocardiography. Ultrasound scanner is an equipment which uses ultrasonic waves for getting images of internal organs of the human body. A doctor may image the patient's organs such as the liver, gallbladder, uterus, kidney, etc. It helps the doctor to detect abnormalities such as stones in the gallbladder and kidney or tumors in different organs. In this technique, the ultrasonic waves travel through the tissues of the body and get reflected from a region where there is a change of tissue density. These waves are then converted into electrical signals that are used to generate images of the organ. These images are then displayed on a monitor or printed on a film. This technique is called ultrasonography. Ultrasonography is also used for examination of the fetus during pregnancy to detect congenital defects and growth abnormalities. Ultrasound may be employed to break small stones formed in the kidneys into fine grains. These grains later get flushed out with urine. Students, let us now discuss about sonar. The acronym sonar stands for Sound, Navigation and Ranging. Sonar is a device that uses ultrasonic waves to measure the distance, direction and speed of underwater objects. How does the sonar work? Sonar consists of a transmitter and a detector and is installed in a boat or a ship, as shown in figure 12.17. The transmitter produces and transmits ultrasonic waves. These waves travel through water and after striking the object on the seabed get reflected back and are sensed by the detector. The detector converts the ultrasonic waves into electrical signals which are appropriately interpreted. The distance of the object that reflected the sound wave can be calculated by knowing the speed of sound in water and the time interval between transmission and reception of the ultrasound. Let the time interval between transmission and reception of ultrasound signals be t and the speed of sound through seabed be v. The total distance 2d travelled by the ultrasound is then 2d is equal to v into t. The above method is called echo-ranging. The sonar technique is used to determine the depth of the sea and to locate underwater hills, valleys, submarine, icebergs, sunken ship, etc. Students, with this we end today's session. In today's class, we have discussed many other concepts of sound, revise all the concepts and revise the answers of the question which we have discussed in this class. Okay? So, keep practicing and keep smiling. Thank you.